All right, so 33, Addison, you took the derivative first? And then what'd you do? Okay. There's something strangely familiar about all of the terms in this polynomial. Yeah, so I can divide everything by 12. So t cubed plus t squared minus t equals 0. Then what? Yep, factor out a t to start with. And then sadly, this right here will not factor. So we have to use the quadratic formula. Did you use the quadratic formula, Ben? You what? Oh, good Lord. So you know that since we factored out this t, one of the answers is that t could equal 0, right? And then we could use the quadratic formula and go opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 1 plus or minus square root of 5 over 2. So the other two answers are negative 1/2 plus root 5 over 2, negative 1/2 minus root 5 over 2. Yeah, you could leave it, you could write your answer as this right here if you wanted to, and it would be. It what? It said 1/2. Did I do something wrong? I don't know. Does that help, Addison? Okay, what did you use the product rule, Jordan? I mean the quotient rule? So this is weird. Addison was asking about this one. They're using y's, but the y's are basically x's. We don't have to do the implicit differentiation thing. They're just, you could rewrite this as f of x, and then everything would be exactly like normal, okay? So low function is y squared minus y plus 1. The derivative of the high function is, the derivative of the high function is 1. So low b high minus high b low. Derivative of the low function is 2y minus 1 over the square of what's below. All right, this is fun. Not just doing the derivative, but like, what do we do now, right? So we definitely have to simplify this. So this times 1 just works out to be the same thing we started with. This I'm going to FOIL. And I'm going to keep the negative sign out in front and use some parentheses, because after I FOIL this stuff, I have to change the sign on everything. Excuse me. So first, 2y squared, outside, negative y, inside, negative 2y, last, plus 1. Still all over, oh, this was supposed to be squared. Y squared minus y plus 1 squared. And then if I simplify this, y squared minus 2y squared is negativo y squared. Negative y plus y, those will cancel, right? And then I still have a negative 2y, so that's plus 2y. And then plus 1 minus 1, that's fun, also cancels. Still over y squared minus y plus 1 squared. Okay? Did I do something wrong? Went pretty fast. You think I'm okay? That's one of my New Year's resolutions, is to make it through an entire day of teaching without making a mistake. At least, yeah, when I think about it, yeah, constantly. Like I forgot this squared, but I caught it, so that doesn't count. All right, so now I have to do two things. I have to set this equal to 0, and I have to find out where it's undefined. To set it equal to 0, I just have to take the top and set it equal to 0, because 0 divided by anything is equal to 0, so I don't care what the bottom equals in this case. So how can I solve that? Factor out can I factor out a negative y? Yeah. So that'll leave me y minus 2 equals 0. So my first two critical points are 0 and 2. Then I also have to figure out where this is undefined, and this will be undefined where the bottom equals 0. So if I set this equal to 0, the first thing I would do is square root it, and the square root of 0 is just 0, so then that leaves me with y squared minus y plus 1 equals 0. This is almost exactly like what we had on the other problem, isn't it? But it was plus, and yeah, this doesn't factor, so we have to quadratic formula again. So y would equal 1 plus or minus the square root of b squared minus 4 times a. Oh, so that's going to end up being negative under the square root, right? Cell phone indigo? Indophone? So that means this has no real answers, and so I can just throw that whole thing away. Made up a new word over Christmas break. When you're with other people and they're all on your phone and you're not, then you are phonely. No, phonely. Like lone. Oh, and they're a bunch of phonies. There you go. I got you. Yeah, yeah. So like sometimes I'm at a restaurant with my wife and I'll see like other couples and one person's on their phone, the other person's just, sitting there. Kinsey? No? Nothing? Okay. That's a rule. That's not a guideline. Okay, so first thing we have to do is take the derivative, right? What'd you get for that, Addison? Okay. And then you take that and set it equal to 0. So what can I factor out of that? Well, let's do the numbers first. What can I factor out of 3/4 and 1/2? 1/2 doesn't go into 3/4 evenly, so I could, but I'd still end up with a fraction. What goes into 3/4 and 1/2 evenly? 1/2 does not go into 3/4 evenly. 3/8 doesn't go into 1/2 evenly. So I'm going to factor out a 1/4. What's the exponent which is lower, negative 1/4 or negative 3/4? Negative 3/4. So I'm going to factor out 1/4 t to the negative 3/4. So that would leave me with a 3. And then this is indigo what you and I were talking about yesterday. To find the exponent on this t, I have to go t to the negative 1/4 divided by t to the negative 3/4. And when you're doing that, you just subtract the exponents, right? So negative 1/4 minus negative 3/4 is really negative 1/4 plus 3/4, which is 2/4. One's negative, one's positive. Negative 1/4 plus 3/4 is 2/4, or 1/2. And then 1/4 goes into 1/2 twice. So there you go. All right, so we should be pretty good at this by now. When is this first piece undefined? 0, so one of our critical numbers is t equals 0. How would I solve this for t? Hey, how's it going?
Hey, I'm doing good. How are you?
Doing awesome. Thank you. Oh, fun. Okay, thanks.
Have a good day.
You too. What will t equal here? 4/9, because I would add 2, divide by 3, and then square both sides. So those are your dealios there. Okay? Are we ready to start running the table, Addison? Should we do 39 and 41 together? Yeah? Probably. Okay, so we got to take the derivative. Two ways we could do this. Well, three really. How much simplifying do you want to do to the original problem before we start taking the derivative? None, a little, or a lot? None, a little, a little. Okay, so let's do a little simplifying. Let's FOIL out this second term and make that x squared minus 8x plus 16. But then let's not distribute the x to the 4/5 through there. Let's just use the product rule from there. So you want to distribute the x to the 4/5? Are you changing it? Well, we still will, yeah. So it's just a question of whether you want to do the product rule from here or distribute and then just do the power rule. Just do the product rule, okay. Okay, so first one, x to the 4/5 times the derivative of the second one plus the second one times the derivative of the first. But then we would have had to chain rule it in the product rule. So when I did, I'd go the first one times the derivative of the second one, and then to take the derivative of x minus 4 squared, I'd put the 2 in front. I guess the derivative of the inside, though, is just, well, it'd still be 2x minus 8. Doesn't matter. What I should have done, Shelby emailed this morning, said she's flooded in. That's why I'm recording this. Could have Skyped. She could have called your phone, and then she'd be here with us. Okay, so then let's distribute this. So that's 2x to the what? 2x to the what? Well, what's x to the 4/5 times x? Add the exponents. How many fifths is x to the first? Yeah, so it'll end up being x to the 9/5. Minus 8x to the 4/5 plus, now I have to backwards distribute this. So that's 4/5 x to the, what? Ooh, this is convenient, somewhat surprising. What's x squared times x to the negative 1/5? X to the 9/5 again, yeah. So that's fun. Minus 8x to the 4/5. Oh, sorry, I forgot 8 times 4/5 is, yeah, okay. 32/5, yeah. X to the 4/5 plus 4 times 16 is 64/5 x to the negative 1/5. Yeah, that's wonderful, isn't it? Okay, got some like terms to combine. Do you want to go 2 and 4/5? Do you want to go 2.8? Do you want to go 14/5? 14/5. We already have some improper fractions running around. We might as well embrace it, right? So 2x to the 9/5 plus 4/5 x to the 9/5 ends up being 14/5 x to the 9/5. That's pretty. And then this is going to be 40/5 minus 32/5 is going to be negative 72/5 x to the 4/5. And then the last one will be already 64/5 x to the negative 1/5. And we have to set that equal to 0. Okay, what goes into 1472 and 64 evenly? 2, is that it? I guess 14 is 2 times 7, so that's it. Okay, so I'm going to factor out 2/5. And I'm also going to factor out x to the -1/5. And that will leave me 7x squared minus 36x plus 32. So that's some fun stuff right there. I doubt that that stuff in parentheses will factor, so you're going to want to use the quadratic formula from there. I'll let you do that. What's the answer to this right here? 0. So we know that x equals 0 is a critical number. And then, like I said, go quadratic formula here, and that'll give you the other 2 critical numbers. You want to take a second on that to finish that on your own? Okay. All right. So last one, a little bit of trig equation solving for you. First, the derivative that you will all screw up if left to your own devices. Not the derivative of 2 cosine x. I'm hoping you would know how to do that on your own. What's the derivative of 2 cosine? -2 sine. Good. But then this one's tricky because sine squared is really like parentheses sine squared, so you have to chain rule it. So I have to put the exponent in front first and make it 2 sine theta, and then I have to take the derivative of the stuff inside, which was sine, so the derivative of that is cosine. And again, that's because I'm thinking of sine squared as being sine theta squared, like that. Good enough? All right, what can I factor out of that? -2 sine. Woo! Sorry, Shelby. All right, -2 sine theta. If I factor that out, that leaves me 1 minus cosine theta equals 0. Yeah? All right, so since those two things multiply together to equal 0, that means each individual piece can equal 0. If I divide this by -2, that leaves me sine theta equals 0. Where does the sine function equal 0? What? At 1? Nope. Pi and 0 and 2 pi and any multiple of pi. Yeah, so theta is going to equal plus or minus k times pi. And k is any whole number. Then if I solve this, that gives me cosine of theta equals 1. Where does cosine equal 1? Or, yeah, pi, 2 pi, no, not, I guess not 2 pi because it's -1, but it's pi, 3 pi, 5 pi, 7 pi. So we already have that, right, for the sine? Because the sine is all the pi's, yeah. So this would be, if you wanted to know how to do an odd number, since this is only the odd values, it would be 2k minus 1 pi. But these two things overlap. So you can really just say any multiple of pi will be a critical number. What was the original function? 2 cosine. Oh yeah, that's right. So here are our, hang on just a second. Let's go. Oh, no, never mind. Hold on. Negative 10 is fine, but I want my step to be. Okay, so critical number, negative 2 pi, negative pi, 0, pi, 2 pi, 3 pi, so forth. All those places are where the derivative is equal to 0, and so we potentially have a maximum or a minimum. All right? Okay. You guys good with that? Okay. So tomorrow we're either going to finish this section or, bless you, do a little bit of a review followed by a quiz, depending on, I don't know, if this is enough to do that or not. Okay? Maybe we should just finish the section before we do that, huh? This is just only one little topic. Is that what you're saying? You feeling skeptical? Feeling like we should do a little bit more before we... Would be gravy then, right? Like, easy? Just one little thing, critical number, take the derivative, set it equal to 0? Okay. I don't know. We'll figure all that out after school.